Greetings and welcome back to Pluralsight. My name is Bruce Mackenzie Lowe and you are watching Advanced Troubleshooting Techniques for Windows Server. In this module, we'll talk about using advanced troubleshooting techniques by putting together much of what you've learned throughout this course. So more specifically, I'll show you how to go about troubleshooting some of the toughest problems out there. I'll start by showing you how to trigger a crash and collect other troubleshooting data when a particular event ID occurs. I'll also show you how to trigger a crash based on perfmon counters. I'll then show you how to view event log entries from a memory dump. I'll then provide you with a couple of demonstrations of implementing the event ID trigger mechanism and also the performance threshold trigger. We'll finish up with a summary of what you've learned. The first technique I'd like to show you is how to trigger a crash when event ID occurs. So, as you may know, intermittent problems are the most challenging ones to troubleshoot, simply because you don't know when they will occur. The good news is that it's possible to trigger an action routine when a particular event occurs. This allows you to capture the right data when the problem occurs, namely you can gather perfmon data, perhaps Windows event trace data, and if necessary, even a kernel memory dump. So, to implement this technique, I'll walk you through the various steps. First, you'll need to set up the initial server configuration. I'll then show you how to set up and configure perfmon logging. I'll then talk about and show you how to configure event tracing for Windows, or ETW logging. We'll then configure Not My Fault, show you how to create an action routine, and how to create a scheduler task, and finally, test your setup. So, to start out with, you'll need to create a working directory. Throughout this module, I'll utilize the working folder C:\troubleshoot. You'll then want to ensure that the kernel logger isn't already running. You can do this with the command logman stop nt-kernel logger -ets for event trace session. Then, if you happen to be running on Windows 2003 or 2008, it's necessary to disable the paging executive if you need stack walking functionality. This can be accomplished via either WPR by doing a -disable paging exec --on, or you can utilize a registry setting. Here you can see the appropriate regadd command specifying the disable paging executive, setting it to a value of 1. Now this next step should look very familiar, as we learned how to establish background perfmon logging in the last module. You'll simply use the logman create counter command to establish a data collector set. In this case, I've created the myperf data collector set with the output going to the working folder C:\troubleshoot with the start of the file name perfmon, giving it a maximum size of 500 megabytes, a binary circular format with a sampling interval of every 2 seconds. And finally, I'm specifying a counter file in the working folder called counters.txt, and this is what that counters.txt file looks like. You can then check and start the data collector set with the logman query myperf command and the logman start myperf command. So the next step is to establish event tracing for Windows logging, or ETW logging. We touched on this in the last module by using WPR and xperf. This time we'll use the nt-kernel logger to accomplish this. You'll simply use the logman command to create the ETW trace. Here you can see I'm using logman create trace, then specifying the nt-kernel logger. I'm specifying the -p profile as the window kernel trace, giving it a set of flags. Then I'm specifying the buffer size, and then the number of buffers, the minimum and the maximum. The mode is circular. The output is going to that working folder called C:\troubleshoot, putting it in a file called kernel.etl. I'm then specifying the clock resolution as performance with a maximum file size of 500 megabytes and the ETS flag for event trace session. Now you note that the flag 0x1002377 is equivalent to the XPerf latency data capture, namely process, thread, image, context switching, DPCs, ISRs, disk, file, hard faults, and profile. Then you'll want to verify that the trace is actually running with the command logman query nt-kernel-logger-ets. So as I previously introduced you to a tool called Not My Fault in the module on troubleshooting system lockups. As you may remember, this tool allows you to force a crash dump. So we'll be using Not My Fault to capture the state of the running system when the intermittent event occurs. So the first step would be to download Not My Fault. You can see the download link on the screen. We would then unzip it into a temporary folder and then extract one of the two images, either notmyfaultc.exe for x86 or notmyfaultc64.exe for x64. Copy that into the working folder c:\troubleshoot. So the next step is to create an action routine, which will execute when the event occurs. As you can see here, I've got a file called gather_data_event.cmd, and that's located in the working folder. And the very first command in that command procedure is a sked task command /change/disable/task name my event test. This is essentially disabling or disarming this task in case it fires again when we don't want it to. Heaven forbid we should get in a never-ending loop of the system crashing just because it experiences a particular event on the reboot. So it's very important to disable the task right off the bat in the action routine. The next command, as you can see, is issuing the logman stop myperf. So we're essentially stopping that perfmon collection that's running in the background because we want to save the data at the time that the event occurs. We want to do the same thing with the logman stop nt-kernel-logger-ets command, as this will preserve the kernel logging data or the ETW data. We then give the system a few seconds. Here I've given a 5-second timeout to sort of pause and wait for all the disk writes to finish up. Then we have to do a registry hack. We need to add a value to accept the EULA. That way, when we fire off the very last command there, the c:\troubleshoot, not my fault c64 space crash space 0x01, it'll allow that to run without having to accept that EULA interactively. So that's in fact how we collect all the troubleshooting data and force a crash from the action routine. The next step is to create the task scheduler job. As you may know, the task scheduler monitors the window event logs and can execute an action routine when a particular event ID occurs. For example, I'm going to use the event ID 1587. So I would use the sked task command to create the task name called myEvent with the task routine c:\troubleshoot gather_data_event.com. You'll remember that's the action routine. Then the other parameters on the command are /sc for the scheduling frequency, which is on event. And the event channel is system with the modifier system event ID 1587. And the /f says to force it whether the scheduler task exists or not, and that we're going to run as the system account. Finally, we can check the task that we've just created with the command skedtask/query/v/taskname myEvent/formatted output the list. Now I did want to note that, as I previously mentioned with the action routine, you can delete or disable this task so it doesn't rearm itself and fire again unnecessarily. Finally, you'll want to test your setup. This can be accomplished by using a dummy event ID, for example, event 123, with a different scheduler task. So here I am creating a duplicate scheduler task almost. You can see it's the sked task command /create/task name equal myEventTest with the action routine troubleshoot /gather_data_event.com. specifying a frequency of on event with the event channel system, but this time The modifier is with event ID 123. And then we run as the system. Now to test this event, we'll actually generate a dummy event with the command event create /l, that's the log file system, an informational event, and the ID is 123. And there's just a description of the event. So this will actually allow you to test your task to see if it indeed recognizes that event and causes the action routine to fire off.